Hey guys, it's Dude Chemistry back on the Food Chemistry podcast. And I just had a question for all of you that when y'all get up in the morning and apply butter on the bread and keep it for toasting, do y'all wonder what reaction is behind that toasting? When y'all go to the cinema hall and go and quickly buy that caramel popcorn before the movie, do y'all wonder how that caramel was made? Today we are going to talk about the reaction which is behind the toasting of bread, which is behind the making of caramel, and many more things. That is nothing but the Maillard reaction. The Maillard reaction is a non-enzymatic, heat-driven reaction. It is a chemical reaction that occurs between amino acids and reducing sugars when subjected to heat, causing a browning reaction that creates new flavors and aromas. For your context, amino acids are the building blocks of proteins, and a reducing sugar is basically a reducing agent. Sugars are divided into monosaccharides, disaccharides, trisaccharides, and polysaccharides. Two monosaccharides joined by a glycosidic linkage form a disaccharide. Like that, we form trisaccharides and polysaccharides as well. For the time being, let us consider monosaccharides like glucose, fructose, and galactose. They all have one thing in common, which is the carbonyl group. The carbonyl group is an organic functional group which has carbon and oxygen bonded by two bonds. Amino acids have the amine group, which is the NH2 group containing nitrogen and hydrogen. The amine group of the amino acid reacts with the carbonyl group of the reducing sugar to give a condensed product, which is a nitrogen substituted glycosylamine, and that nitrogen substituted glycosylamine is brown in color and has the particular aroma. So this is the significance of the Maillard reaction. It forms a nitrogen substituted glycosylamine, which is also a Schiff base, which means carbon and nitrogen are bonded by two bonds in this particular compound, and this compound is the compound which is brown in color and gives us the particular aroma. The Maillard reaction works best in an alkaline medium because an alkaline medium prevents the amine group from reacting with any other group than the carbonyl group on the saccharide. Now let's take some practical life examples. Suppose we have bread and along with that we apply butter on top of it and we put it for toasting. After toasting it, the bread becomes a little more brownish in color. You can easily distinguish a toasted bread and a non-toasted bread by seeing that brown color. And that is because of the Maillard reaction. Now let me explain. Butter has lactose and butter is made from milk and milk contains proteins. So even butter will have proteins. And if butter has proteins, it will have amino acids as well. Amino acids and the lactose react with one another and undergo the Maillard reaction to form a nitrogen substituted glycosylamine. And that is why after toasting, we are providing heat to it. So after toasting, we can see that the bread has turned brown in color. Let's take another example, like the caramelization process. In the caramelization process, most of the people believe that it is simply the pyrolysis of sugar. Pyrolysis means breakdown. So when sugar is heated, it breaks down into particular compounds, and those compounds are the ones which provide the aroma and the flavor of caramel. But I don't believe so. I feel it is completely related to the Maillard reaction. Let me explain how. Now, for the making of caramel, we require butter and sugar. Now, butter is made from milk and milk contains protein. So, even butter contains protein. And as I explained before, proteins are made from amino acids. So, butter contains amino acids and milk contains lactose as well. So, butter contains lactose as well. And lactose is a reducing sugar. So, when we are heating the butter and sugar together, the sugar is breaking down. Yes, no doubt the pyrolysis of sugar is taking place. But in the butter, the amino acids and the lactose is reacting, condensing to form a nitrogen substituted glycosylamine, which is the real one that is giving the flavor and the aroma to the. Well, that was the formation of caramel, and it is so interesting. Now, let me give you a reaction example of the Maillard reaction. Now, suppose I have glucose and I react it with glycine. Glycine is an amino acid and glucose is a monosaccharide reducing sugar. Then, in the product, it forms melanoidin and water. Melanoidin is a Schiff base, which means it contains carbon doubly bonded to nitrogen inside it. And the Schiff base formed, the melanoidin, is brown in color and has a particular aroma. So this is a reaction example of the Maillard reaction, where you can see that in the reaction a compound is being formed, a product is being formed, which is brown in color and is also giving us the aroma. Now, I have explained to y'all how the Maillard reaction is taking place and what exactly is the Maillard reaction. And the Maillard reaction is a reaction which is occurring almost in everyday life. Wherever there's a Browning reaction, there is the Maillard reaction. So now I will leave it up to y'all, the audience, to determine where y'all have seen the Maillard reaction taking place. Do let me know in the comments. And this is your host, Dude Chemistry, signing off. See y'all the next time.